Okay, let me continue. So partition, new topic, coefficient. Partition coefficient. Okay. Now, what is it about it? To দেখো আমরা এই এক্সপেরিমেন্ট এএস এ করছি, আমরা এক্সপেরিমেন্ট গ্রেড 10 এ করছি, 9 এ করছি। Over the years আমরা অনেকবার করছি। It's the first time you're going to do math on it. So A2 is a lot like that. For some of you, A2 will be very easy. Scenario গুলো দেখতে হয়, and so many worksheets. Scenario গুলো দেখতে হয় student, and usually you know most of the scenario, most of the experiments. It's just calculation গুলো কেমনে করতে হবে ওগুলো একবার দেখতে হবে। So I'm running a separate funnel. It could be a burette. ঠিক আছে, যে any device that looks like this. এখন একটার মধ্যে আমি দিলাম, একটা লেয়ারে আমি পানি দিলাম, আরেকটা লেয়ারে আমি ধরো হেক্সেন দিলাম। Okay, hexane. I'm going to use my example first, and then I'll come back to the question. So if I'm studying iodine solution in aqueous, in water, and iodine in hexane. Now see how many topics this spans across. Okay, দেখো কয়টা জিনিস আমি কথা বলবো। This is where A2 ব্যাপারগুলো একটু চ্যালেঞ্জিং হয় for some people. First of all, আমার জানতে হবে from group 7 notes, lab work, whichever, the chlorine water test. See, what's the chlorine water test? It doesn't have to be the chlorine water test. I'm just saying it is our class. I do it with the chlorine water test. Basically. See, what's the chlorine water test? We take a halide. Solution, and we add a layer of hexane or CCl4, something non-polar, something immiscible. Non-polar, polar ওসব জিনিস, তাহলে ওই টপিক রিভাইজ করতেছি না। Polarity of molecules. To understand polarity of molecules, you need to understand electronegativity. To understand electronegativity, you need to understand nuclear attraction factors. To understand that, which is atomic structure chapter, goes back a lot, আর কি, ঠিক আছে এগুলা। So halide solution, আমি যদি এখন এটার মধ্যে chlorine water দিই, aqueous chlorine, like bleach আর কি basically. আজকাল if you guys are using bleach at home to clean because of this COVID situation, ওই যে ওই ব্লিচের মতো, ব্লিচের যে কেমিক্যালটা থাকে ওটাই chlorine water similar property, oxidizing agent. So it will take a halide like I minus, and turn it to I2. মনে আছে আমরা এখানে একটু ঝামেলা ফেস করতাম AS and grade 10. The I2 is actually a solid. It's insoluble in water, but it dissolves in iodide solution to form triiodide. Do you remember that? You want me to revise, anyone? Okay. Actual touch it to put it. So group 7, iodine is actually insoluble in water. Zinc cannot, because it's a non-polar molecule. Its molecules have no dipoles, so they can't attract water. And water, ওইদিকে ও নিজের সাথে কি ফর্ম করে? It forms these very strong hydrogen bonds with itself, relatively strong hydrogen bonds. So পানি iodine এর সাথে মিশতে চায় না basically. But iodine does dissolve. I2 dissolves. Iodine এমন একটা gray black solid. Iodine dissolves in iodide solutions. এইভাবে I minus plus I2 forms this complex ion. What is the ion? Called triiodide. This is the reason for the brown solution. Karjani question, Ridwan. Do you understand? Do you remember the color of iodine? Brown solution? Okay, so ওই কারণে brown solution হয় কারণ iodine তো আসলে গ্রে ব্ল্যাক বাট আমরা ব্রাউন সলিউশন এই কারণে ব্রাউন সলিউশনটাকে ডাইলিউট করলে মনে আছে ইয়েলো হয় ওকে সো এইটা দ্যাটস দ্য টপিক so group 7 galo so you hexane this you cannot why did you put hexane here we put hexane here because iodine যদি থাকে এখানে if iodine is formed by the oxidation of the iodide by the chlorine this will turn pink yes it turns pink as I2 dissolves in it. Do you understand, Shabai, why I2 is dissolving in the hexane? Because the hexane is also nonpolar. Okay, so there are I2 topic, right? Look at how many we're revising. This is how I sneak in my AS recaps. Solubility of molecules. This is the perfect time to talk about solubility of molecules because we're talking about solubility of ionic compounds. না টানা লাস্ট 3 সপ্তাহ ধরে সলিবিলিটি অফ আয়নিক খালি কথা বলতেছি এই এস এ খালি সলিবিলিটি অফ মলিকিউলস নিয়ে কথা বলতে এস একটু মিলালে ইউ লার্ন আ লট অ্যাবাউট সলিবিলিটি সবাই বুঝছো what I'm trying to do okay let's move on so এটা কেন হয় because the iodine is non-polar and the hexane is also non-polar and it dissolves in it so it turns pink or turns purplish pink can I move on okay can someone predict if this equilibrium lies to the right or lies to the left? কোনটাতে বেশি dissolve করে? Right, good. So the equilibrium lies to the right. As iodine is more soluble in non-polar hexane. সবাই এটা বুঝছো? So again দেখো এগুলো আমি কিছু নাও পড়ালে you guys can argue and say hey we understand because we understand AS and we understand what you taught us about KC. So this thing will have a relatively high KC. Like if I give you a question, edX as the MCQ format, Cambridge তোমাদের অন্যটায় পাশে you'll see actually. KC যদি আমি বলি ABCD, pick the KC. KC কি 20, KC কি 1, KC কি 0.1, KC কি 0.4. কোনটা নেব? 20. কেন 20? Justify your answer যদি বলে why 20? The answer is 20. Why 20? Equilibrium lies to the right because concentration of I2 at equilibrium in hexane is much greater than concentration of I2 aqueous. সবাই কি বুঝতেছো? Concentration of I2 is more in the right বলো না দেখো everyone instantly clicks yes but answer দিছে শুধু আফশাফি and আবরার so I'm not sure how there's an instant yes সবার থেকে it's just a complete mismatch which is fine তোমরা যদি if you guys are happy with how it's going আমার সমস্যা নাই I'm just saying I don't understand the mismatch right maybe সামনে লিখতে যাচ্ছ না if that's the situation তাহলে ঠিক আছে তাহলে I'm not worried but what I'm worried about and why I get worked up is because I think most people aren't really understanding this yes stuff so we have to if that's the situation, maybe I'm being paranoid, right? If that is the situation, though, that is so stupid, you you guys spending time and money and you guys are doing that. Make me happy. It's stupid at the plan. There's no one more stupid than that person right now. So anyways, সবাই বুঝছো? Yes, but let me move. So next, concentration of I2 is greater, so okay, yellow. Next nation. The Kc here, the Kc is concentration of I2 in hexane. How can I like this? Divided by the concentration of I2 in an aqueous solution. Are we clear? Okay. Now, এটাকে আমরা Kc বলি না, এটাকে আমরা বলি K partition, because the solute is partitioned between two solvents. You understand? Partition, and it's distributed across two different solvents. Did any school, I'm pretty sure Corona, but did any school do high performance liquid chromatography, GLC, HPLC, column chromatography? Na? Okay. Excel most likely আগে করবা, Unit 4 এ যেত. Cambridge also pretty, you guys won't be too far behind them. তোমাদের যেন এটা পড়াবে স্কুলে HPLC, GLC. A lot of people don't understand HPLC and GLC and stuff. আমি বুঝতাম না, আমি যে জিনিস এখন পড়াই তোমাদেরকে, আমি এটা আসলে if I'm being honest, আমি বুঝতাম না. I got a 90 in A2 chemistry, but আমি বুঝতাম না এটা, and I was lucky আসে না পরীক্ষা. যদি বড় একটা টপিক আসতো আমি পারতাম না, right? So when I started teaching, then I had to teach myself, right? I had to do my own work and understand it. Because স্কুলে কোনো টিচার আমাকে এটা পড়াতো না. যে স্টুডেন্ট ধরো 80 to 90 পাইছে, ওই মানুষকে যদি বুঝতে না পারে, odds are most people don't understand this. Yeah, and every year একটা জিনিস আসছে। আমি just একটা কথা বলে বের করছি। The way they approach this sometimes in school is too much of words, and they don't highlight certain bits of information. So when I do this again, আমি just তোমাদেরকে সিকোয়েন্সটা বলতেছি, তোমাদের মনে থাকবে না এগুলা, তাছাড়া বলছি একটু নোটস লিখে রাখো। This idea of partitioning is going to be used in two applications. It's going to be used in one, solvent extraction. Have you heard of that? Yes, full topic শুনছো? A levels है ना आगे break देना है topic. I just want to know school की बात से. Which topic? Yes, let's move on. So you're correct, Naima, but I'm coming to that example that I gave you. If you did that with me, or you remember grade 10 or IGCSE particular, but there's a very common example in like at the end of A2. You do this usually at the end of A2, where it's an application where it's like, just give me an example, simple example of solvent extraction. The basha every day আমাদের চা যখন আমরা বানাই, that's solvent extraction. আমরা চা পাতা থেকে we take off the caffeine, the flavor, the color, the aroma of the tea. If you use coffee beans, not instant coffee. Instant coffee is just making a solution because it's like a soluble powder dissolving in water. But if you go to a coffee shop, or if you have a coffee machine at home, you have to buy ground coffee beans, or if you have a coffee grinder, you might buy coffee beans. Most of us usually don't use coffee beans. If you have a coffee machine at home, you probably have a ground coffee machine, like ground coffee. You know what I'm talking about, Shaman? So coffee shops গুলোতে দেখো না যে বড় the baristas are using those big espresso machines. তারপর they make these drinks for us. Like say if you like cappuccino or you like a latte, it has different amounts of milk basically, steamed milk, foam milk, and but the all coffee starts with like a base, which is the espresso. Shop barista they take espresso. Sometimes some drinks have a double shot of espresso. তারপর ধরো steamed milk, foam milk, etc. layers থাকে. So depending on what kind of coffee you like, তোমার milk কম বা বেশি, milk something etc. ওই যে espressoটা যেটা বানায় ওরা কালো লিকুইডটা, ওইটা বানাইতে গেলে they use these coffee beans through which they pass hot water and steam hot water basically, and the hot water basically dissolves the caffeine and the flavors and the taste molecules from the coffee beans. But a lot of the coffee beans is insoluble. It's like the beachy mocha, like seeds, right? If you know what I'm saying, like orange seeds or apple seeds, or they don't dissolve in water, right? They're completely insoluble. So they have these hard shells on them. So they're like that, insoluble. So what a bucket to fill it. That's an example of solvent extraction. We use the solvent, hot water, to extract something from a chemical. Where do we use this in industry? It's used in medicine preparation. It's used in any kind of chemical preparation. There's a আমি coffee beans খাইতে পারছি না because ওটা আমার গলায় আটকাবে, and it's just unpleasant if you try to swallow it, right? It's like literally like swallowing sand, right? Or drinking sand, or এরকম মানে solid আটকে যাবে তোমার গলায়. So I don't want that, but I want the other chemicals that are giving the coffee its flavor, that make the espresso, right? So if you think বাসায় তাহলে আমার কফি মেশিন না থাকলে চা যখন বানাবো একটু জিজ্ঞেস করি আমার চা পাতাটা তো খাই না, আমার চা পাতাটা থেকে we take out the chemicals. That is solvent extraction. Look at the word, the name, and you'll understand the terms of it. Bishop advanced chemistry topics. That's why I talk about words and language so much. Solvent there, extract both the sectors that you want. Okay, so they'll ask you this a lot towards the end of the syllabus, and one more. So let's keep it at that. The other one is in chromatography. Can't explain this right now. We'll come back to it. Break it for. We'll come back to it much later. So break it for. We'll talk about the math involved here and what's going on in this experiment, basically. Yes, so take a break. Okay, guys, I'm going to continue করি. So let me just give you one last bit of information here. Then you guys solve the question. So uh, solvent extraction, it's like making coffee. We're going to do this in the analysis chapter. Okay, so course outline দেখবে একটা chapter আছে called analysis. দুটাই ওখানে করব. We'll do a lot of new techniques like steam distillation for Cambridge. We'll do many different types of chromatography for both Cambridge and Excel. Steam distillation for Excel, for recrystallization for both batches, mainly at Excel. Excel gets a lot more questions on it. Cambridge or Vishashna. So what you need to understand is আমার যদি একটা aqueous solution থাকে and I want to extract iodine from it, right? আমি এই liquid দুটাকে mix করে একটু শুনে নাও, liquid দুটাকে mix করে I'm going to shake it and let it reach equilibrium. I'm saying what will happen when it reaches equilibrium. When it reaches equilibrium, as the iodine that is here will go here. And it's going to turn it pink or purple, which is ASR example. Are we clear? Pink or purplish. So if you think so, what's the benefit of this? আমার যদি একটা chemical reaction করে, let's say if I'm making an ester, you all did esters last in grade 10 and last year in Cambridge course. To make the reaction যখন বানাচ্ছো, there's going to be leftover reactants sometimes, there's going to be byproducts. অনেক জিনিস থাকে যেটা তুমি সব চাচ্ছ না, তুমি একটা ওষুধ বানাতে চাচ্ছ না, you want to make some air freshener maybe, you need the fragrance molecules. অন্য chemicals লাগছে না যেটা process use করে. Those other chemicals might be toxic. Those other chemicals might give it a bad smell if it's a food product. Or আমার এইসব powdered juice যখন আমরা খাই, fake powdered juice বা fake juices in general, যেগুলো not actual fruit juice, right? ওই bottle juice যেগুলো আমরা অনেক সময় খাই, we get those artificial juices. ওরা ওই ফ্রেগরেন্সটা কেমনে আনতেছে? They're making basically these chemicals in a lab, in a chemical reaction, right? So a chemical reaction অনেক সময় byproducts থাকতে পারে, which literally could be harmful for us, or it could be toxic if it builds up, or it could just give the thing a bad taste. So দেখবে অনেক সময় থাকে না different brands, দুটাই fake juice, কিন্তু একটা একটু better, একটা একটু খারাপ, and sometimes they can't do the extraction properly, sometimes অন্য chemicals চলে আসে, and this is where you need the you need applications in chemical engineering. যারা এইসব fields এ ঢুকবা, you learn way more techniques like this, but A2 gives you a nice like a teaser of what's to come, basically যারা এইসব লাইনে ঢুকবে, so ওরা টুকটাক একটু জিজ্ঞেস করবে তোমাদেরকে, and এইসব টপিক তোমার চিন্তা করো grade 9 থেকে 8 থেকে করতেছো. Separation technique and analysis was some of the first few chapters the student does in chemistry. Filtration bolo, distillation bolo, fractional distillation, these were all grade 10 topics. Grade 11 এ বেশি নতুন কিছু শিখবে, grade 12 এ আবার নতুন জিনিস আসবে. So analysis and separation techniques is always based on physical properties and solubility and stuff like this, right? Melting point, boiling point, solubility. So all these physical techniques, solvent extraction, chromatography, distillation, filtration, মোটামুটি সবগুলোতে boiling point বা solubility একটা implication আছে. You get my point, সবাই? So আজকে just theory. I like breaking down these chapters এইভাবে. আজকে just theory, but often if Cambridge students want to read this up, let's say, we'll go through your book again at the end after entropy is done. When you want to read through this from your book, it'll usually be written very well in the analysis section. বইয়ের একদম শেষের দিকে. Okay, clear, সবাই? Let's move on. So এখানে if you think what's happening here, আমি কেন বললাম তোমরা পড়ে আমাকে জানাও শেষ হবে, because this is you can see it's a partial question. এখানে দুটো question combined, acid base and equilibrium was combined at Excel. So এখানে এই যে এরকম টাইপ কোয়েশ্চেন করতে বলতেছে পাশে, ঠিক আছে, 20 মার্কস এর মতো every weekend পারলে একটা দুটো করো from your problem area, যেগুলো আমরা কভার করছি বা যেগুলো স্কুলে কভার করছো. So you see what did they do here? They did a titration between ammonia. The titration above can be used to determine the concentration of ammonia concentration of ammonia solution when ammonia is distributed between two immiscible solvents. So this person had ammonia aqueous ammonia নিছিল, and ওখানে আরেকটা সলভেন্ট দিছিল, shake, keep it for some time, always keep it for some time বলবা যেমন কেএসপি কোশ্চেন এইমাত্র করছি তাই না স্যাচুরেটেড সলিউশন when something has to reach equilibrium তুমি যখন বুঝতেছো এখানে একটা equilibrium aspect আছে always bolba let it equilibrium to give it some time so this person had aqueous ammonia and this person had this thing CHCl3 trichloromethane so I mean hexane use করছি আমার lecture ওরা use করতেছে trichloromethane they could use whatever they want here because anything at all that they give you তোমরা solve করবা in the exam so 75 cm cube of 4 mole per dm cube aqueous ammonia and 75 cm cube of trichloromethane I'm assuming the trichloromethane is less than I'm not really sure okay so I have 75 cm cube of each if this is I'm assuming this is trichloromethane I'll have to google the number the density so if this is trichloromethane so there is no ammonia when I start do you agree Shaban? There is no ammonia there is only trichloromethane right so I had 75 cm cube of 4 mole per dm cube aqueous ammonia so I have an initial number of moles right so if using equilibrium লিখবা কেমনে so দিদিছে দেখো ওরা aqueous ডান দিকে লিখছে so does that change anything not really because I could reverse it if I want but usually we write aqueous on the left hand side conventionally but it's not really wrong if you write aqueous on the other side because তোমরা যখন তখন বলছো the value will be high AC value will be high yeah if I তোমরা 20 বলছিলাম আমরা right if I flip it it'll be 1/20 and if I write aqueous on the right hand side of the equation সবাই বুঝতেছো so that doesn't change the mathematical meaning of the value so that's a good thing about AC values তোমার equation দেখে তুমি decide করবা কি দিছে ওরা তোমার so এখানে if I stick with what they give me I have ammonia CHCl3 and I have aqueous ammonia initial number of moles বের করো 4/1000 sorry 5/1000 75/1000 someone help me out into 4 don't write just now just আমাকে নাম্বারটা বলো 0.3 moles don't write anything yet আমি তাই করে দিচ্ছি একটু শুনে নাও smaller lecture than a worksheet the worksheetটা নিচে okay so please শুনে নাও so calculate the number of moles of ammonia and hence the concentration in mole per dm cube of the aqueous layer the number of moles বের করছি change and at equilibrium is what we normally do let's see কি চাচ্ছো calculate the number of moles of ammonia and hence the concentration in the aqueous layer now to understand this I need to read the next line in the paragraph the two liquids are allowed to separate and 25 cm cube of the aqueous layer is taken with the pivot and titrated with 4 mole per dm cube hydrochloric acid. The whole procedure is repeated. So this is not the moles that they want. They are asking, after I reach equilibrium, কতটুকু ammonia আছে? So if I can find the number of H plus in the titration, someone help me out. Titer volume 24. 24 divided by 1000 into 4 mole per dm cube. কত এটা? .096. So তাহলে that's the amount of moles because সবাই বুঝছো এক্সপেরিমেন্টটা কি হচ্ছে? Everyone? Okay. So তাহলে that's my number of moles in 25 cm. এখন খেয়াল রাখো ওরা চাচ্ছে আমার থেকে কনসেন্ট্রেশন আমি কিন্তু এখানে ক্যালকুলেশন করছি মোলস এর moles there. So if this is my number of moles of HCl, this is my number of moles of ammonia in the 25 cm cube sample. সবাই বুঝছো? Okay. So my concentration of ammonia at equilibrium, because these were equilibrium numbers, is number C is equal to N by P. So number of moles is 0.096 divided by 25 divided by 1000, which becomes multiplied by 1000. ঠিক করছে সবাই?